Welcome everyone to today's JUMP Academic webinar, Essential Statistical Tests. I'm Ross Methusalem. I'm here to host and manage the Q&A today, and my colleague Kevin Pochner, a JUMP Academic Ambassador, will be presenting. Today's webinar, which is designed for academic researchers with little to no statistics background, is meant to teach you a core set of statistical tests for use in your research. And really, these tests are broadly applicable to many different use cases. But if you are a researcher and you have data and accompanying questions like, did the treatment we applied have an effect? Or do these two groups differ along some measure? Or I have two measures. Are these correlated or related in some way? Today, you're going to learn the statistical tests that you need to answer those kinds of questions. And you'll, of course, learn how to perform those tests in JUMP. Now, before we get started, I do want to encourage you to ask any questions you have, big or small, throughout the webinar today. Please use Zoom's Q&A panel to ask your questions. So you'll find the Q&A under that little overlapping speech bubble icon that you see in your Zoom interface. Please put your questions there for us to answer. If you have general comments to make or you want to address the other attendees, please feel free to use the chat. But again, please put your questions into the Q&A for us. So without further ado then, let's get started. Kevin, are you there?
I am.
Wonderful. Take it away.
Okay, and can you confirm you see the screen fully and that nothing is getting cut off?
I'm not seeing the screen yet, but let me see. And there it is.
All right, perfect. All right.
And yes, it looks good. So have at it.
Thank you. Okay, welcome everyone. And so as Ross had shared, we're going to talk about statistical inference. And we're going to sort of look at, the two main scenarios where the outcome variable is something numeric, like a continuous numeric variable, and the outcome variable is something categorical, like a binary yes, no. Before we dive into JUMP, this article came out last week in Scientific American, and there's a link to it right there. I'll just slide it over. Some of you may know this and some of you may not, but the origin of the t-test actually comes from Guinness Brewery, from a brewer named William Gossett. And so this little article, it's very, very short, but it just talks about how at that time, and this is the late 1800s, early 1900s, there was no techniques for small sample inference. And so William Gossett invented basically the t-distribution. And so this kind of discusses it. It actually shows a little bit of math. It's not too complicated, but shows a little bit of, how it kind of works, this origin of the p-value. The norm, scroll down here. Here's, the difference between the normal distribution and the t-distribution. It's a super short article. When I teach, I always like to mention this in class. I feel like, well, maybe if I start talking about beer, I'm going to get students' attention. So if any of you are teaching, encourage you to share this article with your students. They may find this interesting, and the history of basically this is the history of, I would say, is statistics in general, experimental design and everything. So I just wanted to share that with you. It actually just came out last week. Okay. The other thing I want to direct your attention to is all of our resources. I'm not going to click on these to show you them all for preservation of time, so I want to dive into using JUMP. But if you click on these links, you're going to get sent to our how-to guides. We have a collection of, I think, 90 plus videos and printed guides on how to run a whole collection of analyses in JUMP, from basic stuff like graphing all the way to advanced stuff like generalized linear mixed models. But this is something that a lot of faculty send their students to, so their students aren't coming to them with, hey, how do I do this analysis? You can just point them to the guides. We have a collection of webinars recorded in our library. It's where this one is going to get posted up, but encourage you to go there to learn other techniques and other capabilities of JUMP. This Mastering JUMP webinar series, that's put together by our commercial team, but those cover topics that would be relevant to academics as well, especially in a kind of a research environment. We have these enhanced data sets and case studies. Now, all the examples I'm going to use today are going to be from our enhanced data sets or case studies. So You're going to, I'm going to open some of them up so you'll see what those are. But if you go to these pages, you'll see a large collection of them. And we also have a lot of books. And so if you go to this section, you'll see a combination of textbooks that feature JMP, but also books that we put out that are sort of not so much textbooks, but more as reference books. It's teaching some statistics, but it's mostly about how to do those analyses in JMP. But for preservation time, I'm not going to go to those, but I wanted to provide those links in the journal for you. So let's jump right in. Okay, so we're going to start off with doing inference for the mean. And this first example I'm going to use, this is actually one of our case studies. So if you're not familiar with our case studies, this is what they look like. So this happens to be about a food manufacturing process. This is a company that's manufacturing yogurt. And so in our case studies, there'll be a description of the statistical techniques, the JMP platforms that are going to be used. There's some background to the problem, description of the variables and how the data was collected. This particular example has specifications on the process that the manufacturer is desiring the pH to be. And then what our case studies do is they step through some analyses. So they show you how to do that in JMP, how to interpret the results in JMP. And this one goes through everything from creating some graphs to conducting some hypothesis tests on the mean, checking assumptions, does some hypothesis tests on the variability. And then the way these end is at the very end, we're just kind of scrolling through quickly. At the very end, there'll be a set of exercises that, well, you can do it on your own just for learning, but if you're teaching a class, these are great to hand out as student assignments. And as faculty, if you reach out to us, we'll provide you with the solutions. So I'm going to do this one for a demonstration. Let me open up the data set. And so basically what the problem is we've got 8 production lines that are making this yogurt. And we're just calling them lines A through H. And over a period of time, 30 batches of material were sampled, and then the pH measured on each batch. And you can see all that data here. So this case study illustrates the analysis on one of the lines, line A, and then the exercises is to do the analyses on the remaining 7 lines. Well, let's just start off with graphing data. That's pretty much how you begin any analysis. And I think in JMP, we pride ourselves on the tools for visualization, interactive visualization. Now, I'm going to do this first with the graph builder. Now, any analysis you do in JMP, you're going to get graphics and visualization. So we think there should always be some kind of graphical visualization with every analysis. So you're going to see graphs everywhere. But if you're just sort of creating a graph not tied to a specific analysis, you want to launch our graph builder. And if you're not familiar with this, it's basically a blank canvas waiting for you to make a graph. And you just start dragging variables into different roles in the graph and then choosing different graph types. And I'm going to start doing that. So you'll see kind of how this works. So I'm going to pick up line A, the pH, and you see how all those areas turn blue. So it's like, oh, where do you want to put it? So I'm like, oh, maybe I want to put it on the x-axis. And if I put it there, now JMP's default for numeric data is to do a dot plot. If you wanted it to say be a box plot instead, you can go up here and click on box plot. If you want to see both, you can click on the box, hold the shift key down and click on the dots and you'll get both. Or maybe you want a histogram, you can get a histogram. Maybe you want this on the y-axis instead. I'm going to go back to the dots. So you see you're interactively building a graph. Now, I'm going to choose to show the confidence interval for the mean. And so right here, this happens to be where it shows the fitted line. And so what that means in this example is it's going to, the model is going to fit as the mean. So that's why it shows the mean and the confidence interval. I can even show the prediction interval. I can show the mean and standard deviation. Now, this particular process has specifications. So it has a target of 4.35 and a lower spec of 4.3, upper spec of 4.4. So what you can do in graphs and JMP is you can add those lines to the graph. So you double click on the axis, you'll pull up the axis settings, and you can do lots of things here, like tick marks and fonts and colors and all that. But what I'm going to do here is I'm going to add these specifications. And so I always like to make the target green. And I always like to make the low and upper spec limit red. So I'm just going to add those and click OK. And now you'll see these get added. Oh, and all our graphs are interactive. You can grab the axis, slide it up and down. If you go up to the top, then you can sort of collapse and expand, like you're changing actually the axis range. Now what I'm going to do is I'm going to sort of plop this in the center. Okay. Now I have 7 other production lines: line B, line C, line D, and line E. So I can go ahead and make those if I want. Make another graph for B, make another graph for C. But Jump has this really great tool in it, and this exists everywhere in Jump, not just the graph builder. I use this one all the time. You can launch this tool called the column switcher. And now, right now, only one variable is being used, line A. But what I'm going to tell Jump is I want to swap that out with line A through H. Click OK. And then over here on the left, you're going to see this thing called the column switcher. Now that allows me to change what variable is on the y-axis. Before I do that, there's 2 things I want to do. One is I want to lock the scales, because as I go through the different lines, I don't want the scale just changing. I want to keep it fixed. And then the other thing I need to do is retain axis settings. And that's what that's going to retain is the spec limits I put on there. So now over here, I can just swap between the different lines, and now I can see the data points as well as the confidence interval for the mean, and I can compare that to the target and specification. Now, if you haven't used Jump before, if you want to save this graph to your file, you click red triangle, save script to data table. You give it a name. I already have it saved, so I'm not going to do it, but you just click OK. And then what's going to happen is inside of the file up here, this is where your scripts get saved. Then that would just get added. I've already done some analyses. That's why there's some stuff saved there already. Okay. Now, if I wanted to see, let's start over. I'm going to remove the column switcher. If I grab all the variables and drag them on the x-axis, then I'm setting this up to sort of do some comparative analyses. Okay, and so now I'm sort of looking at the variation and where it is located. And if I wanted to, I'm not going to do it for preservation time, but I could add those spec limits to that if I wanted to. But the main thing I wanted to do with this data is to do some inference. Now, whenever you're doing a univariate analysis, okay, whether it's categorical variable or a numeric variable, you want to launch our distribution platform. Now, what this is going to do, and I'm going to put all the 8 production lines in there, and I click OK. And what I'm going to get is, well, anytime you run an analysis in Jump, it's going to start off with some initial output. And then from there, it's where you do more output. Okay, so don't think of when you run Jump as you run some analysis and get a static piece of output. You're launching a platform, an interactive platform. So I put every production line in there so you can see how big this report is, because I got line A, line B. But for each one, it basically starts off with some graphs. We got a histogram, we got some box plots, and we've got some summary statistics. Oh, actually, you know what I'm going to do is I'm going to stack this instead. Okay, so now the way I've set this up here, and so now the report has all of these stacked on top of each other. And in fact, I can also close, expand and close these tables, which might be nice because the report can get kind of large when you start adding things. So I'm just going to do some analyses on line A. So I'm just going to go back here. So the target is 4.35. So a natural thing to do is test the hypothesis if the mean is 4.35 or not. So when you drop down these red triangles, these items in this menu are all going to be things you would do with a numeric continuous variable. If it was a categorical variable, these menu items would look different. So one thing I can do here is, well, I can test the mean. So I'm going to click on this. A little dialog box pops up, obviously wanting me to tell what the value I'm testing under the null hypothesis. Hit that, click OK. And then now the results of the t-test get added over here to the report. Now you look like, oh, there's another red triangle. What's that? This particular set of tools under this red triangle open up some interactive, I would say these are more like teaching tools, right? So if you're teaching the concept of a p-value, you can go in here, interact with this, change values. We also have one on power. So if you're teaching the concept of a type 2 error in power, you can interact with this, or again, type numbers in to do different things. This is more for a teaching environment, not a research environment, but you'll find these things everywhere in JMP. We've got a lot of interactive teaching tools. Now, we might want to check the assumption on the t-test, and one of the assumptions is that the normal distribution is an appropriate model to use. And if you, I know when you learn this in an academic setting, it's specified like, well, this is an assumption, and if you derive the mathematics, it is. It's just one of those assumptions that the procedure is not super sensitive to it, especially in our case where we've got 30 observations. But nonetheless, I'm going to do that. So I'm going to drop the red triangle down, and what I'm going to do is I'm going to ask JMP, well, why don't you fit a normal distribution to these data? So when I click fit normal, a few things are going to happen. One is I've got a histogram, a normal distribution drawn over that histogram. Oh, almost all output in JMP you can resize. So if you grab it, see how I can kind of play with this if I want. You can even zoom in, zoom out. So we can look at that graph as a way to assess normality. But if I scroll over here, I actually have the ability to run those formal tests. So I can do a goodness of fit test. And so you see how this now gets added. There's my p-values. JMP is printing out 2 tests here, Shapiro-Wilks, Anderson-Darling. Here's another red triangle. I'm going to open up this one. I like this particular graph a lot. I'm going to make it bigger so you can see it. So here is the normal distribution CDF, cumulative distribution function, and I can interact with this. And so as I move across the x-axis, in this case pH values, over here on the left, I'm seeing, well, what's the cumulative probability along with a confidence interval around that. So I've got a fitted normal distribution. So in this particular exercise, it has students, if you give this out as an assignment, I'm just scrolling through real fast, sorry, then it has them do all of those analyses that we just did, along with some others I'm not showing, on lines B through H. And what this one is about, and I should show this graph, I should have shown this graph as well. I'm going to pull up the graph builder one more time. Because this data is collected in time order, I'm going to show it also in time order. Okay. And I'm going to drop on the spec limits again real fast. And bring up my column switcher. Okay, swap them all out, and I just want to lock my scales again and retain access settings. And so now as you switch through the different production lines, now we're getting a sense of, well, are things changing over time? And we can see that in some cases, right? We can see like, oh, maybe that's a little bit of a shift upward at some point after maybe a dozen batches. This one has got some extreme values happening. This one has an obvious non-stable pattern there. So what the exercises are all about is having the students assess, well, which production lines do I feel safe doing inference on? And so it's sort of trying to get at, for example, line F here, you're like, it's probably a stretch to think this is somehow representative of how that production line runs, right? So why would I use that sample to draw inference? And so it's trying to get students to understand that some of these production lines, sure, I can describe it graphically and maybe some numeric values, but I don't feel safe doing kind of any inference beyond the data I've got. All right. Now I'm about to close this example, Ross, but before I do, just want to check in to see if any questions.
Oh, we've gotten them all handled in the Q&A so far, so I think you can keep going.
Perfect, thank you. Okay, this is an example of one of our enhanced data sets. Now, these are like the case studies in the sense of we describe what statistical techniques and JUMP platforms are featured in the problem. There's a description of the problem statement, given some context, some background. In this case, it describes how the experiment was conducted, description of the variables. But instead of it demonstrating a bunch of analyses like the case studies do, it goes right to the exercises. And sometimes at the end, there's actually some reference materials that you might want to incorporate, complementary materials you might want to incorporate in the class. So what this data set is about is a clothing retailer wants to run some online experiments. And so what they do is they expose viewers to 4 different advertisement styles and 3 different promotional offers. So basically what's happening is if you're on a website and the ad pops up, you're going to see one of 4 of the ads and you're going to be offered one of the 3 promotions. Now, for the purpose of this example, I'm just going to do one of the factors. I mean, this is technically a 2-factor ANOVA, but I'm just going to show an analysis on the 4 different ad styles. Now, do you think they ran this experiment on one website? Of course they didn't. So they actually ran this experiment across 20 different websites, and the outcome variable is click-through rate. And that's how most online performance is measured, is how many times you've seen, basically it's per impressions, and it could be per 1,000 impressions, per 10,000 impressions, per 100,000 impressions, but basically how many times does this viewer, in this case, how many times does this girl click on the ad to take a look at the product based upon the amount of times that it's being viewed. Okay, so if I launch the graph builder, I'll start with that one. So I'm going to go click-through rate for website 1, put that there. This is very similar to what we did with the yogurt. I'm going to put ad style down the bottom, and now I've got the 4 ad styles. Now, if I did want to incorporate promotion, I could come around here, and where do I want to put promotion? I could put it there as a panel. I could put it over here. I could put it inside ad style, outside. So if you were working in promotion, I would drag that variable into different places and have it incorporated in the graph. But for this one, I just want to focus on ad style. Now, even though there's platforms where we do more formal analyses, we can do some things from here. Like I can ask to see the F-test if I want. I can see the means and standard deviation. Now, this is another example where I've got 20 outcome variables. And so what I want to do is I would really want to do the column switcher. And so now I can examine where the differences are in these ad styles across the 20 websites. When I teach, I love to use examples like this where there's just not one outcome variable, because I feel like it goes too quickly. You have students do it, where I think it's better and actually more realistic is, hey, you know what? Well, there's 20 websites we did this experiment on, or maybe there's 50 websites, and then they have to kind of explore all the different ones, and in this case, find out, oh, these are the ones that are significant, these are the ones that are not. Now, to do a formal analysis of variance, I actually launched this platform called FitY by X. So whenever you're doing any kind of bivariate analysis, this is the platform you want to launch. Now, I am going to put website 1 as the outcome variable and ad style as the X. And when I hit OK, JUMP's going to start off with some initial output, which in this case is just this graph. But here's my red triangle. So when I click on this, these are all going to be things you would do if you have a continuous numeric outcome variable and a categorical X. If I had a categorical Y and say continuous X, well, this menu item would look different. It would actually have performed a logistic regression. Now I'm going to click on means ANOVA. So I click on that and some familiar output with analysis of variance is produced, like the analysis of variance table. I've got confidence intervals for each level and some graphs. I got a little diagram representing those. And I'm just going to click on a couple more items like, well, maybe I want to do multiple comparisons. So we've got a few different multiple comparisons. I'll pick student T's. And then, as you see, don't think when you run analysis in JMP, you're running an analysis and getting a piece of static output. You're launching an interactive platform. And yeah, I've been doing statistics for 25 plus years. I've even worked for other software companies, and I just feel like this is the best way. It kind of aligns with how you think, how you explore and analyze data. It's unfolding. You don't know everything at the beginning you want to do. You look at results, and then you think of the thing you want to do next. So in this case, I'm getting all sorts of output for doing multiple comparisons. Now, this particular website, nothing was significant, so I didn't really need to do multiple comparisons. But this is where, if I really wanted to look at all 20, instead of creating 20 different reports, which I could create a different report for each website, but it's probably a lot more efficient if you just create one report and set up the column switcher. And then now I can go through all 20. And then if you were keeping an eye, I don't know where you were looking, but if you're keeping an eye down there, you can start to see the ones that are significant. And if you did explore this data, what you would notice is add style 4 is one that underperforms a lot from the other 3. And then if I want to save this to the data table, red triangle, save script, data table, give it a name, hit OK, and then it would be saved. So what you'll find with this approach with JMP is you'll have much fewer pieces of output, much fewer graphs, and in this case, ANOVA reports, because you can just set up that column switcher as opposed to having 20 graphs and 20 analysis of variances saved up here. You'll just have one for one specific analysis, and then the ability to look at any variable you want. Now, I'm not going to do this, but there's add style and promotion. So technically, this is a two-factor ANOVA, but for this webinar, I'm not getting into that. I'm just doing the one-way ANOVA. But if you go and grab this enhanced data set, these exercises actually step you through doing that. All right. I'm going to close this example up. Ross, do a little check.
Sure. We just actually had a quick question I typed in an answer, but maybe you could show some folks really quickly just about customizing some of these graphs that you've been making, for example, changing the font size or the label on an axis.
Perfect. I'll work that into the next example here.
Great.
Okay. So here's another one of our enhanced data sets. This is an experiment that a psychologist did. In fact, at the end here, you can see the original article or the research paper. There's also an article in a psychology publication, and there's a video where the researcher talks about how they did the experiment and what it was all about. And so if you are incorporating it into a classroom, this is a good one because now you've got some resources you can direct your students to. But basically, this is an experiment that a psychologist did where they had owners interact with other dogs. Well, technically it's a stuffed animal, but they had their owner interact with a stuffed animal dog as well as just an arbitrary object. And they measured how much force their dog kind of pulled on a leash to, run towards the owner. And they're using that force as a way to measure sort of how jealous that dog is. Do they think their owner's interacting with the dog? Are they going to pull more than if they just see their owner interacting with, it turns out it's just this little cylinder object. So I'm going to open the data set here. So in this data set, we have 18 dogs. And these two variables here are basically the pull force that dog exerted on the chain if they saw their owner interact with the dog versus seeing them interact with just this inanimate object. So this is an example, if you're kind of understanding the setup of a paired t-test. So I wouldn't just want to do a two-sample t-test comparing dog to cylinder because, well, the dogs are different. So some dogs are just going to say naturally pull more than others, regardless of what their owner is doing. And so we have to correct for that. For those of you who know this technique, you know you can kind of do it two ways. One way that you can do it is just subtract the two, create a new variable, which is dog minus cylinder, and then you do a one sample t-test, testing if the mean is 0 or not. But we have a platform that's designed for doing it as a paired t-test, so you don't have to create that column if you don't want to. And that particular procedure is under this menu, specialized modeling, matched pairs. So I'm going to click on that. You put, in this case, the two response variables, which is the pull force from the dog and pull force from the cylinder. You just put them both in there. You click OK. And then now you're going to get some output for a paired t-test. So down the bottom here, you're going to see the test statistic, the p-value, some other measures like the confidence interval of the difference. And this graph up here is a neat way to represent the data. So on the y-axis is the difference, and then on the x-axis is the mean. And the red solid line there is basically the difference. So it's this value right there. And then here is the confidence interval for the difference, and that's those dotted lines. So basically those two dotted lines and that solid red line, that's a graphical representation of the confidence interval shown on a graph where we're plotting the difference versus the mean. Now, to Ross's point, let's say I made some changes to this graph. So I could double click on an axis and everything maybe I want to I'll put some grid lines on there. I can change fonts. Remember, I added some reference lines, so I click OK. So in this graph, it added those grid lines. I'm going to click on the red triangle, for example, and I'm going to click, I'm just going to pick something, plot percent difference by mean. So here's another graph that I've added. So this is similar to this one up here, but now it's plotting the percent difference, which that might maybe be a better way to approach it. Because obviously if the dog is, say, pulling a force of 10 and it goes to 20, well, now that's doubled, right? That's 100%. But if you're over here 300, 400, 500, it would have to be a extremely large difference to be 100%. So in addition to editing graphs, I said, like by clicking on them, or you can right click on them and you'll have options here. Okay, so I can change different properties if I want. So let's say you made a whole bunch of changes, and it's a common way that when you run this analysis, you want the output to be. Well, we just added this feature in 18. And so whenever you've got some output on the screen, you're going to see in the upper right these little stars here. And these are called presets. And so if you click on this, I have the ability to save this as a preset. And if I clicked on, I'm not going to do it, but if I clicked on this, I would give it a name. And then now, whenever I'm in this platform and I go under the presets button, I don't have any save right now because I didn't do it, but then it would be saved. So I'm showing it here for a simple example, but it's pretty common. You run analyses, you make all sorts of changes, you drop down the red triangle. There's a whole bunch of standard things you do. And if you do it every single time, then you can save that. And then all you have to do is to go into your presets and select it, and then you'll get all the output the way you want. Now, there's also things you can do under our preference menu. And so these kind of go together, like the presets and preferences in a way. But I can go through here, for example, and make changes. I'm just clicking on it quickly just so you can see. But like I can make changes to how graphs look, changes to fonts, some styles. I can actually go into let's see, I can actually go into specific platforms. So I'll pick one here, like we did, let me find one we did, oh, fit Y by X. So I can go in here and select items that are actually under the red triangle. I'm just clicking quickly just so you can see there's all sorts of things here. I can go in here and select, hey, every time I run these analysis, I want you to always show these graphs or show these things because that's just how I do it. And so there's a lot of things you can do in preferences where now you've changed it globally. Okay, so between presets and preferences, you can not only make the changes, but actually have those always active. Ross, was that what you think the question was getting at?
Yeah, I think so. It was just very general about, trying to customize these graphs in different ways. So I think that's good.
Okay. Oh, and here's the thing too. I always get this where people say, "Can Jump do X?" And then I always say, double click on it or right click on it because that right you double click on it or right click on it, menus are going to pop up or dialog boxes are going to pop up, and then that will kind of show you what to do. So that's kind of a good way to start. Okay, so moving along, this next example I'm going to go to is inference for a categorical outcome. Now, this is another one of our enhanced data sets. And what this one is about is a company that manufactures packaging bottles that are used for pharmaceutical products. And when these are developed, they run tests on children. And obviously the intent is that children can't open them up. So what this story is about is it describes how this experiment was done. They actually have let me see, is this, oh yeah, here we go. They actually have 200 children between 42 and 51 months of age, and then there's 10 boys and 10 girls for each. And over a 2-day period, each child gets 4 different packages to see if they can open them. And they basically are given 5 minutes. And so basically you'll see that the children have 5 minutes to open up the package. If they don't after 5 minutes, then the test stops. So obviously we're hoping the children can't open it. And so there's a description of the experiment, the variables, and then all sorts of exercises for analyses that to run. I'm obviously not going to do all of them. I'm just going to pick a couple. So here's the data set. So we have the child ID, age, gender, the one of 4 designs, A, B, C, or D. We also have things like the testing order, which is done randomly. So each child is not seeing the designs in the exact same order. And for each child and each design, there's 2 rows. And so the way these experiments are done, and in fact, if you go to this enhanced data set, it's sort of referencing the Consumer Product Safety Commission and FDA and what is established as the standard used is basically the child is given, in this case, this little bottle that would be holding a pharmaceutical. They are given the package and they see if they can open it in 5 minutes. And then they see it demonstrated. So then a person is just going to do it in front of them, not explaining it and teaching them how to do it, just like, okay, now you're going to watch, basically watching an adult open the package. And then they have another chance to open it to see if if they see it demonstrated, they can do it. And there's actually 2 outcome variables. One is, did they open it or not? Yes or no. And as you can see, most of them are no, which is good. And then for anyone that is able to open it, I'll scroll down to come across a couple. And here's one. Anyone that is successful opening it, then they record the time it takes to open. But I'm going to do all the analysis on the binary outcome variable, yes or no. Now I'm going to open up some of this output I have saved first so you can see where we're going. And so this graph is called the mosaic plot, and it's basically where you've got these stacked bars for the percentage of yes and no's, and then I have it for each design and each demonstration level before and after. So this is the graph I'm going to make. I just wanted to show you where I was going. Slide that over here. Okay. And so now I'm going to launch the graph builder. Okay, remember, it's a blank canvas waiting for you to make a graph. So if I just grab the outcome variable open and place it here, well, it's just going to start off by just putting dots, the number of no's and number of yeses. But what I want is the mosaic plot. So I'll click on that. And so now I'm seeing basically stacked bars for yes or no with the percentage. And I can choose to add, like, for example, add the percent. So of all the total number of times trials in the experiment, 3.7% of the time it was opened and 96.3 it was not. Now I don't have the design in there and the demonstration level, so I obviously want to do that. So again, you pick a variable up and you decide, well, where do I want to put it? Well, maybe I want to put it down here. Seems like a logical place. And so now I've got it separated by design. But I've got that before and after kind of collapsed in there. And so I can grab demonstration. Again, where do I want to put it? I can put it up here, and now it's paneling it. I can put it this way, and that's kind of putting it on top of each other. I can put it on the inside. I could put it on the outside. And you'll just find certain graphs are easier to communicate what you want to look at. And so let it go, and there it is. Now, to that question earlier, Ross was like, how do you customize graphs? Well, I've got a graph here. And you might say, well, I don't like those colors. Well, come over here and right click on the colors, and what do you know? I can pick other colors. I can even sort of choose transparencies. If I double click here's on an axis, well, here are my axis settings. And then I would see like what kinds of things I can change. And here I would notice like, oh, actually, I can type in different values than what's actually in the data set if I want. I'm not going to make any changes, but there's just an example where I double clicked or right clicked and saw some options. Okay. Now what I'm going to do, I just opened up so you see where I'm going to go. I'm actually going to create bar charts, counts and frequencies, and confidence intervals for the proportion of times the child was able to open the package or not for each design and each demonstration level. So you'll basically see that I've got 4 different analyses, and I'm going to produce this. Let me slide it aside. Well, as I said earlier, when you're doing a univariate analysis, which we are here, I'm going to do a univariate analysis on each design and each demonstration level. So I'm going to launch the distribution platform. I'm going to put open. And what I can do now is I can put in design and demonstration as a bivariable. And then now when I hit OK, I'm now going to get some output for each design and demonstration level. So there'll be 8 pieces there. And here are my red triangles. So if I click on, for example, the red triangle, this is where I can do things like maybe I want to do a hypothesis test about the proportion. But what I'm going to do is I'm going to choose to add 95% confidence intervals. And then that just gets added right there. Now I could go through one by one, but if you hold down, well, it's the Mac is the command key. I'm remembering what if you're using Microsoft, but if you hold the command key down and ask for anything, then it's going to provide that for all items below it. So if I chose confidence intervals, then you see that I now have confidence intervals for all 8. Yeah. So when if you looked up this information that's in the enhanced data set on the Consumer Protection Agency, there's basically criteria that a package must satisfy. It's like a certain percentage of children would not be able to open a certain package. So you can compare those confidence intervals to those values. Okay, let's see what other. Oh, I'm going to show this graph just because I think it's really cool. Okay, so here's a heat map of all of the experimental trials. I think this one's probably the best way I would show the data. So I'm going to make this. I'll slide it aside, but I'm going to show you what we're going to do here. Okay, so I'm going to pull up the graph builder again. Now I'm going to put the child ID on the x-axis. Okay. And choose heat map. So basically right now I haven't given it any information yet other than child ID. So I'm just basically getting an item for for each here. But if I go over and say, put in design here and demonstration, I'll put that, let's see, I'll do that on the inside. Okay. Now it's just the cell for right now for each thing. So I haven't given it the outcome variable yet. So now I'm gonna take this variable open. And if I go over here and put it on the color, okay, now basically each cell is one of the experimental conditions, the design and the demonstration for each child. And now I've got it color coded, whether they open it or not. Again, if you don't like the colors, just right click and change them. So I think this really summarizes it well, because so far we just looked at the percentage of times, but what we didn't look at is, well, there's the age of the child. They start off at 42 months and they go all the way to 51 months. And so this graph is making it clear that as the children get older, then they're starting to be able to open it up, in some designs more than others. So for example, here's design C, and you can see that there's quite a bit, especially after the demonstration. So because of this, what I'm going to do is I'm going to do a logistic regression where the age of the child is going to be my X variable. Now, I'm going to do this as a bivariate analysis as well. So I'm going to do fit Y by X. My outcome variable is open. Age is my X variable. And then what I'm going to do is I'm actually going to put design and demonstration as my bivariable. And so what I'm going to get when I click OK, there's some cases where there's 0. Let me just close them all up at first. Just like I did with the distribution platform, then I'm going to get, well, provided there's at least an outcome, but I'm going to get logistic regression analyses for each design and each demonstration period. And you got some graphs, you got some numerical output. Again, lots of red triangles. Whenever you see the red triangles, this is where you can pull up other options. Like maybe I wanted to display the odds ratio, for example, and I can do that. Now, this was doing individual, basically, I basically did individual logistic regressions for all 8 combinations. Again, I'm not getting design A before, because it's actually, no one was able to open up the package at all. If you wanted to approach this as a multiple variable logistic regression, as opposed to doing separate ones, then that's where you launch our fit model platform. And for the preservation of time, I'm not going to do that, because I'm focusing on more simple techniques for this webinar. But fit model is where you build any kind of model with multiple X's, whether it's a logistic regression model or it's a standard regression model, mixed models. I just opened this up just so you can see a large collection of modeling that you can do here. And this is pretty much all the ones that you would be doing with any kind of model building process, all the way up to generalized linear mixed models. Generalized regression, you can do stepwise from here. So this would be where I'd say build a multiple logistic regression model, where I'd put, maybe I'd even work in gender, maybe bring in age, gender, design, demonstration. Maybe I'd check for interactions. I would do all that in the fit model platform. But again, I encourage you to, if you go to our other webinars here, we've got webinars on building regression models specifically. So I encourage you to go there if you want to learn more. Okay, and let me see if there's anything else I wanted to cover in this one. No, that will be it. I'm going to close this example and go to the last one. But before I do, how are we doing on questions, Ross?
Oh, we're doing all right, keeping up with them in the Q&A. With just
Okay.
about 10 minutes to go, I guess we can finish it up and then see if we have time for a few more questions at the end.
Yeah, and I don't have any meetings when this ends. So if anybody has questions and wants to stay on, I'd be happy to do that and answer any questions you have. Not just about I'm demonstrating, but just jump in general. So if you want to talk about any other topic, I'd be happy to stay on to do that. But I'm going to close this example up and go to the last one. And here is where I'm going to do linear regression. And so this is another one of our enhanced data sets. And what this data is about is this researcher, and there's actually a reference to the paper here. This researcher is studying the relationship between the amount of sleep particular mammals have on average and their gestation period. So again, there's a description of the problem. You'll see the jump tools and techniques that are going to be illustrated, description of the data, and then a bunch of exercises that if you were doing this in a classroom environment, you could assign to your students. And so there's 80, well, I'll say there's 79 mammals plus I added 2 rows for human adult and human baby because we're going to kind of look at how those compare to the rest of the data. And I basically have gestation, and then I have total sleep, which is just the sum of REM and non-REM. Okay. Now I'm going to do something a little interesting here. Oh, so do you see the red dot and the blue dot there? So that's something called the row state. So if you select some rows, and basically what I did is I selected, say, human adult, and I went under the rows menu, color, and I picked a particular color, or I could pick a particular marker. And I turn those on. So as we look at graphs, we'll see those. Now there's another interesting thing I can do. I'm going to grab those. When I go into the rows menu, I can choose a few different things. So for example, I can choose to hide and exclude those 2 rows. In other words, I'm not going to see them in any graphs, and they're not going to be part of any calculation. I could also choose to exclude them, but not hide them. And I'm actually going to do that. So if I hit exclude, what's going to happen? And now you'll see that's the symbol for exclude. Any analysis I do going forward, and I'm going to do some regression analyses, it's not going to use those rows in any of the calculations to build the models, but I'm going to see the points on the graph. Okay, so you have a couple of those options there, right? You can hide it, you can exclude it, or hide it, or do both if you want, but I want to exclude it, but I want to see it. Okay, so I'm going to just open up the graph I'm going to make just so you see where I'm going here. So I'm going to make a graph that's going to put the sleep variables on the y-axis, and I can switch between them, and then gestation on the x. Actually, you know what? For preservation time, I'm just going to focus on REM. Okay. So I'm going to go in the graph menu. I'm going to put REM here, gestation here. Okay. Now again, by default, jump fits a smoother, which you can actually play with how much smoothing there is if you want, or you can choose to fit it as a linear regression. Now, you might be looking at this and saying, I don't know if a linear regression is a great idea, because when you went to the smoother, you saw that kind of shape going on. A couple things you could do. If you right-click on the axis settings, I can change, for example, let me put them on the log scale. And so now, and maybe I want to put them both on the log scale. Oops, I got to do some resizing here. Okay, so now I can put these axes on the log scale, and now you probably feel a lot better about that regression relationship with stuff on the log scale. And I can see the equation if I want, the R squared, I can put the F test. So there's a bunch of basic things you can do with an analysis from the graph builder. But what you're more likely to do is to be using the fit y by x, because I want to get a lot of output, not just those few pieces. So I'm going to put REM on the y. I'm going to put gestation on the x and click OK. And like everything else in JMP, it starts off with just a graph, and you drop the red triangle to do more things. So I could say fit a line, and it's going to fit that least squares line because I asked it to. And so here's all the output of fitting a regression equation, yx, no transformation. And then I can ask for all sorts of other things, but I'm going to remove it because what I really want to do instead, from when I looked at that graph builder, is I want to fit log y, log x. So I got at that by, oops, I gotta hit OK first. When I went under the red triangle, there's other models we can fit, like polynomials, and I chose fit, we can fit orthogonal regression. I chose fit special, and this is where the transformations are. And so I did that. And so now, I'm gonna make this bigger so you can see it. Oh, there's the, I was like, where's the baby? Okay, there's the baby up there. So there's the human baby, there's the human adult. You can see how much I don't have any children, never had any children, but for those of you who do, and you know how much your baby sleeps, though from what I understand, not when you want it to be sleeping, but you can see how much REM a human baby sleeps relative to the gestation period. So the way I did this analysis, remember, is it's not using that data to fit the model. But I wanted to see where the human baby and the human adult lie on that graph. And so now I fit this log model. Now, another way I could have done this is I could actually take the log transformation of all of these variables and have them actually in my data table. So I'm just going to grab them all, right click, and I'm going to say new formula column log. I'm going to do the natural log. And so now I just automatically created a transformation of all those variables. So if I did that, then I could say, okay, I'm going to just put in the log variables. Okay, so now the data has been transformed. The scales are linear, but I transform the data. So here I would be choosing fit line because I have done the transformation, and because now the analyses are on the log. And one last thing you can do whenever you are running an analysis in JMP, and so I'll do this with the graph builder just to illustrate. Pretend these logs aren't there, okay? Well, I'll make it easier to not pretend they're not there. I'll actually remove them. So when you go into a platform in JMP, and over on the left, you see the list of variables. Something you can do is if you right click on a variable, you can create a temporary local variable. And so, for example, I can say, I'll pick the log of gestation and the log of REM. And then what you're going to see in the variable list on the left is I've got those two variables, but notice they're in italic. And so that's telling me that, yes, I can use this variable for the purpose of this platform I'm in, like in this case, this graph, but I actually didn't create those variables, and they're not going to be available when I open up another platform. They're not in, see, they're not in the data table. They're just available locally here. So this was an example of doing simple linear regression, and I guess the one part of it that's a little bit more complicated than just a basic one is that we worked with transformations for the y and the x. And if I go back to the fit y by x platform, here's my red triangle. I might want to do things like save the fitted values and residuals, or the confidence intervals, or maybe I want to plot the residuals. I'll do that. And then now I've got all my standard residual plots added. And I'll just say this one more time because this is such a great feature. If I go through here and do all sorts of things like changing the graph, dropping down the red triangle, and doing all sorts of things, and I'll add the confidence interval shaded on the graph. If I hit preset and I can say save preset, I give it a name, and then every time I launch this platform, it would be listed under my presets. Oh, actually, I already saved that one, bivariate with residual plots. JMP also adds some. So if you go under sample presets, we actually put some in there already. So you can have them all. Oops. Okay, perfect. I know we're at the top of the hour. I will hang out as long as anyone wants, if they want to talk about other topics or the topics we did cover. But with that, Ross, is there anything specific you want me to address?
Yeah, I have two. First, we've had some interest in these enhanced data sets that you've been showing, and I don't recall yet if we have solutions available to the exercises in those PDFs. So can you speak to that?
Yes. So what if you reach out to us, and you can send me an email, I'll put, I think it was at the top, but I'll just put it again in the chat window. If you send an email, what I will do is, well, first I got to verify you're a faculty and you're not a student. I will send you the data set that has all of the analyses results saved. I don't have any write-up for them, so it's not as if I'm going to write paragraphs of interpreting all of them, leaving that up to you, but I have the analyses saved.
All right, great. And last one, and please just correct me if you showed it and I maybe missed it while I was in the Q&A, but in fit y by x with two continuous variables, just how to pull up the simple correlation and confidence interval on that correlation.
Oh, yes. I believe this is going to work. Let's see here. All right. And you're going to help me find it here.
Oh yeah, so if you go to the summary statistics,
there we go.
that's where it lies. Yeah, so just one quick additional place, and I, personally found that a lot of folks, understandably, you click the red triangle here and just look for correlation, and that's not an option, but it's under the summary statistics where JUMP considers the correlation to be like a primary summary statistic when you're analyzing two continuous variables. But I think that's it as far as the open questions go. So we'll hang out here for a few more minutes just to see what other questions come in. But thanks everybody for attending. I hope you got some value out of this. Kevin, thanks for another great webinar as usual. And we hope to see you all at the next one.
Perfect. All right. Thank you.
I do see one just came in, actually, Kevin. Let's see. Does JUMP have resources to assist with what types of analysis may be helpful given the data type in question? For example, here's my data. Do I do a t-test or a paired t-test or an ANOVA? Do you want to show them how to find the data analysis director add-in?
Yes, and you're going to have to help me with this.
Sure, yeah. If you just go to the community, we can find it there.
Okay, and what is it? What is the title?
So if you just look at data analysis director. So here, Kevin's at community.jump.com.
Okay, am I searching for it or is there a drop down?
Yeah, if you just go to data analysis director, it should pull it up. And there it is. The very first hit that you see, data analysis director in JUMP add-ins. This will, this add-in file, if you download it and double click it, it will install an item under your add-ins menu in JUMP that does what is suggested by this question, that is direct you towards the appropriate statistical test or analysis given the scenario that you're in. So when you click on there, yeah, it looks like it was hanging on Kevin there for a second. Kevin, did we go to the page? Doesn't look like we're at the page for that specific add-in. This is the full add-in list.
Yes, I never put this into my.
So if you just click on data analysis director right above Pete Hirsch's name, it'll take you to the page.
There we go. Okay.
And then on the right where it says attachments, everyone, you will see the top one, data analysis director.jump add-in. And then when you double click the file that you download, it will install the data analysis director add-in into your version of JUMP. And you can see some screenshots right there of what it is. So for example, the first bit will ask you the analysis task. What do you want to do? Maybe you want to compare groups. Maybe you want to study a measurement system. Maybe you want to, let's see, some of these other, small text, describe a group. And then once you click on one of those, you get some follow-up questions to provide a little more detail, and eventually it will tell you exactly the statistical technique recommended. In the example here, it's a 2-sample t-test, and it shows you where to find it in JUMP. So if you need some guidance as far as choosing the appropriate statistical method or test, go to community.jump.com and download that Data Analysis Director add-in.
Okay, I just popped in the link in the chat. So when you download the add-in, see the icon that I'm moving around on my desktop there. I just downloaded it, and then all you have to do is grab it and then drop it on the Jump icon, click install, and then I don't know if do I have to quit? Oh, there it is. I don't know if I had to quit.
There it
And then
is.
now under your add-ins, you'll have, and if it's your first one, obviously there's only gonna be one listed there. I've got some other things here.